Welcome back with another episode on tryhackme.com. This is Zahir Nazir and we are doing Linux Fundamental Part 3. This is the second video on this path. In the previous video, we had completed from task 1 to task 4. We're gonna start from the task 5. We already started the attack box and also the attached machine, as you can see. Let's continue with the processes 101. Processes are programs that are running on your machine. They are managed by kernel, where each process will have an ID associated with it, also known as PID, process ID. The process ID increments for the order in which the process started or starts. I.e., for example, 60th process will have PID of 60. All right, let me close it for now. Let's see if I open up my terminal, type ps. As you can see, these are the processes that we have. We have bash and we have ps as well. All right, so the process ID is 3212. That means there are 3211 process before this process was created. Some of them would be still running and some of them would be died already. All right. Viewing processes, we can use the friendly ps command to provide a list of the running processes as our user session and some additional information such as its status code, the session that is running it, how much usage time of the CPU it is using, and the name of the actual process or the command that is being executed. So as you can see in the picture here, they are trying to say that, okay, the PS is running with PID 204. And then if you do PS again, for me, the IDs are same, but here ID is changed. I don't know why. All right. Note how in the screenshot above, the second process PS has a PID of 204, and then in the command below, it is then incremented to 205. Okay, let's do one thing. What if I add more tab? I still have the, okay, wait. Yeah, the PS is changed, right? So in this tab, as you can see, the processes IDs are changed. And in here, processes IDs are similar to what we had, but this 3664 3656 and also the bash ID is changed. All right, you see the processes run by other users and those that don't run from a session. System processes, we need to provide auxiliary to the ps command like so. Ps auxiliary aux. Oh, there are a lot, man. There are a lot of processes. So let's see what was the process. Okay, so the process which run all other processes is sbin init. Okay, so this is the process who will initiate everything else. Because why? Because this is the PID, parent ID. That means this is the process that initiated everything else. All right. Awesome. And we can see that some of the users are running other processes. For example, root is running Python, m.web something, and then we have www.data user as well, system D. That means these are running from the system itself. Then we have light dm. I don't know what that is, but maybe this is also a user. Proscree, that means there is a db running, and there are other as well, syslog and whatnot. All right. Now we can see a total of 5 processes. Note how we now have root and cmnatic. Another very useful command is the top command. Top gives you real-time statistics about the processes running on your system instead of one-time view. These statistics will refresh every 10 seconds, but will also refresh when you use the arrow key. to browse the various rows. Another great command to gain insight into your system is via top command. Okay, let's try this. top, and here we go. So whenever I press arrow key, it is refreshing. Okay, I will press Ctrl C to come out of it. Managing processes. You can send signals that terminate processes. There are a variety of types of signals that correlate to exactly how cleanly the process is dealt with by the kernel. To kill a process, we can use the appropriate named kill command and the associated PID that we wish to kill. Kill PID 1337, we would use kill 1337. Before we do that, let's try one thing here. For example, let's kill 4152. No such process. Why? Oh, the process ID is changing every time. Okay. Beware. Below are some of the signals that we can send to a process when it is killed. Sigterm, kill the process but allow it to do some cleanup tasks beforehand. Sigkill, kill the process, does not do any cleanup after the fact. Sigstop, stop, suspend a process. Okay, how do a process start? Let's start off by talking about namespaces. The operating system OS using namespaces to ultimately split up the resources available on the computer to such as CPU, RAM, and priority processes. Think of it as splitting your computer up into slices, similar to a cake. Processes within the slice will have access to a certain amount of computing power. However, it will be a small portion of what is actually available to every process overall. Namespaces are great for security as it is a way of isolating processes from one and another. Only those that are in the same namespace will be able to see each other. That is true. We previously talked about how PID works, and this is where it comes into play. The process with an ID of 0 is a process that is started when the system boots. Okay, so there is a process with ID 0, but we saw that the init process had the PID 1, right? Okay. The process with an ID of 0 is a process that is started when the system boots. The process in the system's init on Ubuntu, such as systemd, which is used to provide a way of managing users' processes and sits in between the operating system and the user. For example, once a system boots and it initializes, systemd is one of the first processes that are started. I don't think so. PS orgs. I did not see 0 in here. And where is the systemd exactly? I don't see any systemd. Okay, wait, let us search. Systemd. So systemd started in Nginx, but the ID is 2284, man. And in here, 930. This is systemd. Okay. Yeah, I don't see it anywhere near starting point. Yeah, I don't see it here. Okay, so that is not true, by the way, for this particular attack box. Maybe it is true. Okay, let's see what I have in my own Kali Linux. Okay. So here we go. So I have this some SB, but where is the full name, man? Okay, so here is the full name. Let's see what we have here. So it was started by init, but I don't see systemd even here, which is close to, yeah, there is a worker, but all of them are started by root, right? So I don't have to say, okay. So this may be true for Ubuntu, but not for the Kali Linux or the Kali Linux version or the Parrot or the Kali Linux version of the attack box. All right, which is used to provide a way of managing users' processes and sits in between the operating system and the user. For example, once a system boots, its initialized systemd is one of the first processes that are started. It is not true for Kali Linux, maybe true for Ubuntu. Any program or piece of software that we wanted to start will start as what's known as a child process of systemd. This means that it is controlled by systemd but will run as its own process. Okay, although sharing the resources from systemd to make it easier for us to identify and the likes. Okay, getting processes and services to start on boot. Some application can be started on the boot of the system that we own, for example, web servers, database servers, or file transfer servers. This software is often critical and is often told to start during the boot up of the system by administrator. That is very true. If the server is running as a web server, if it is rebooted, you want the web server to start as soon as possible. Once it is rebooted and come back it is accessible. In this example, we are going to be telling the Apache web server to be starting Apache manually and then telling the system to launch Apache 2 on boot. Enter the use of systemctl, system control. Okay, this command allows us to interact with the systemd process daemon. Continuing on with our example, systemctl is an easy to use command that takes the following formatting: systemctl and then the option and then the service. For example, to tell Apache to start up, we'll be using systemctl start Apache 2. Let's try that. Systemctl, that means system control, then the option we want to start it, then Apache 2. If it is already installed, then it should start, and then I think we can say systemctl status Apache 2, and here is the status of the service. As you can see, it is active and it is running, and this Apache 2 have started other services as well, reloading, and this is the end of it. Okay, I press Ctrl C to come out of it. All right, we can do 4 options with this systemctl: start, stop, enable, or disable, and status as well, right? So what if I do man systemctl to learn more about it? So there are options. Let's see what we have in option. We have state, we have P for property, we have A for all or reverse, after, before, L, show types, fail. There are a lot of parameters, and these are the commands and patterns. Okay, left. I will press just Ctrl C to come out of it, or Q to quit it. You can go ahead and learn about systemctl, and it is a big man page that you can take a look at, because there are a lot of options and a lot of parameters or arguments that you can pass to systemctl. An introduction to background and foreground in the Linux. Processes can run in two states, in the background and in the foreground. For example, command that you run in your terminal, such as echo or things of that sort, will run in the foreground of your terminal, and it is the only command provided that hasn't been told to run in the background. Echo is a great example, as the output of the echo will return to you in the foreground but would not in the background. Take the screenshot below for example. Okay, so let's do that. We do echo hi THM. THM is try hack me. As you can see, the output is there. Hi try hack me. And if I do echo and that, it will it returned me the information and also show me this is the background process it is running with. All right, okay. Here we are running echo higher THM, and where we expect the output to be returned to us like it is at the start, but after adding the AND operator to the command, we are instead just giving the ID of the echo process rather than actual output, as it is running in the background. It is great for commands such as copying files, because it means that we can run the command in the background and continue on with whatever further commands we wish to execute. Usually, in practice, we usually create either a new terminal or open up a new tab to do the same, because we want to see what happened with our command beforehand. All right, because it means this is great for the commands such as copying the file, because it means that we can run the command in the background and continue to on with whatever further commands we wish to execute without having to wait for the file copy to finish first. But this AND command is very useful once you are doing actual hacking on the system that you have permission to hack on. Basically what you do is you have just one terminal to execute your own commands, right? And it is also sometimes RCE is not available, remote command execution, or the bash shell is not available. So in this case, if you need to run some commands in parallel, you can use and run some of the commands in the background, while your terminal will be available to run further commands and give you the output at the same time. Okay, this is great for commands such as copying files, because it means that we can run the command in the background and continue whatever further commands we wish to execute without having to wait for the file copy to finish first. We can do the exact same when executing things like scripts. Rather than relying on the AND operator, we can use Ctrl-Z on our keyboard to background a process. It is also an effective way of pausing the execution of the script or command, like in the example below. This will keep on looping until I stop it. So Ctrl-Z, they press it, and that means it will stop the process itself. The script will keep on repeating. This will keep on looping until I stop or suspend the process by using Ctrl+Z as indicated by T $Z or T power of Z. Now our terminal is no longer filled up with the messages until we foreground it, which we will discuss below. All right. Foregrounding a process. Now that we have a process running in the background, for example, our script background.sh. Do we have this script? We have a folder. Let's see what we have here. We don't have a similar background script, but okay, it's okay. Let's continue. Which can be confirmed by using the ps auxiliary command. We can backpedal and bring this process back to the foreground to interact with. Okay, With our process background, use the control Z or AND operator. We can use FG to bring this back to focus, like below, where we can see the FG command is being used to bring the background process back into use on the terminal, where the output of the script is now returned to us. Okay, we can do one thing, by the way. Let's do Python 3-m http.server. Okay, let's run it. I'll press Control Z and it went to the background. Let's see PS. As you can see, the Python 3 is running on 5909. So I will do FG. Just press FG. Just type FG, and once you do it, the process which is running in the background, the first one, will pop back in. Okay, so FG, for example, if I do F909, does it work? Yeah, it does not work. But if we just do the FG, as you can see, the Python 3-m HTTP server bring to the foreground. Okay, now if I press Control C, I think this will basically stop the process. As you can see, there is no longer Python there, and if I do FG, nothing is there. Okay, readme, we did that. If we were to launch a process where the previous ID was 300, what would the ID of the new process will be? 301, because it is incrementing by 1. If we wanted to cleanly kill a process, what signal would we send it? It is sig. Wait a minute. Sig term. Come on. Look at the process that is running on the deployed instance. What flag is given? What? Use the Excel to list all the running process. We are looking for a process that seems out of ordinary. All right. PSOUX. So we are looking for a process which is out of ordinary. Don't see such process. Actually, I don't see such process here. Maybe we can search. What about this? Let's find. I don't have it. What is the flag? What flag is given? Look at the process that is running on the deployed instance. 1 minute. Deployed instance is this one. 196.34. Yeah, okay, so we need to SSH then in this case. All right, SSH try hack me at 10.196.34. Enter. Yes. Password is try hack me PSAUX. And we are looking for, yeah, here it is. THM process. Actually, I need to render it in a full screen in order to view it all. Just a moment. Okay, so it is still concatenating, not running as I want it to. Okay, come on. Okay, so here we are, PS AUX. Why it is not responding? What happened here? A moment. It just stuck. I don't know what happened here. Let's run the command again. Yeah, so this is what we were looking for. Copy, paste here, submit. Awesome. What command would we use to stop the service, my service? Okay, systemctl stop and then service name. Systemctl stop my service. This should work. All right. What command would we use to start the same service on the boot up of this system? Option and service. What command would we use to start the same service on the boot up of the system? Maybe we need to enable it. So it is systemctl enable my service. All right. What command would we use to bring a previously background process back to foreground? FG, of course. Awesome. So we are 8 minutes into the video, so I'm gonna stop the video for now. If you like this video, please give it a thumbs up. If you haven't subscribed, please subscribe to the channel. Help us build the community, and I will see you in the next part.